Hello, welcome to another video. Today I'm going to show you how to create a urban fire risk map using 4 variables: the building typology, the floors of each building, the proximity to emergency services, and also the width of access roads. So without further ado, let's get to the video. So first we are going to use the response time of the firemen. So if the fire station is 100 meters or less from the urban fire, it will have a risk value of very low, 250 meters low, 500 meters medium, 1000 meters high, and 5000 meters or more very high. Next, we are going to use the floors of each building. So buildings with more floors have a higher risk of battling the fire. So for one floor we will have a risk value of 1, 2, 2, 3, 3, 4, 4, and 5 and 6 floors, a risk value of 5, very high. Next we are going to use the streets width. So if the streets are more narrow, it will be difficult to fight the fire. So 1 meter and 2 meters, so we'll have a value of very high. So 1 meter and 2 meters, the fire truck cannot access the building, so it will have a value of very high. 3 meters medium, 4 meters a level 2 low, and 6 meters a larger road will be a value of 1 very low. Finally, we are also using the building topology. So for administrative services we will use the very low risk value. For bank, municipal services, and police station, the level 2. Chapel and housing 3. Library, shopping centers, social center and school, level 4. And then for storage and theaters we will have a risk value of very high. So, and the steps we are going to take are these 5 steps here that we are going to create this map in Arcgis Pro. So if we open Arcgis Pro, we have here 1, 2, 3, 4, 5 shapefiles. First, we have the fire station. The location of the fire station is out of our area of interest. As you can see, this is the area of interest. Then we have buildings and others as well. And if we open the attribute table, we can see the fields we have. So we have the field of the topology, as you can see, and also the floors for each one of the buildings. Then we have the streets, with streets width, so 1 meter, 2 meters, 3, 4, and 6 meters. As you can see here, we have narrow streets near this part. And finally, we have also the response time of the firemen from the fire station. So as you see here, actually we can, yeah, it's here. We have 100 meters, 250, 500, 1000, and 5000 meters. Okay, so buildings that are in this red zone will have a risk value of 5, here 4, 3, 2, and 1, and we will need to adjust these values also to these risk values here that we saw moments ago. So what we need to do first, if we go here to the steps, we need to add risk values to the buildings and other shapefile for the topology and floors. Okay, I'm going to place this Excel file here and Arcgis Pro here side by side, and we are going to first start with the building topology. Okay, so if we go to the buildings and open the attribute table, I will sort this ascending to be the same as this alphabetical order as the Excel file, and we are going to select the administrative services. Actually, first we need to create a new field, and I will call this R for risk and B typology. This will be a double type, and we can save. We can actually create all the values right now, so we don't need to do this later. So let me just click here to create a new field, and I will add har floors double as well. We can create our response time and our streets and data type will be double as well. Change, save the changes, and we can now start filling these fields here. So first, let's start with the topology. We selected administrative services, right click inside a field, calculate field, and this will have a risk value, as you can see here, f of 1. Okay, so we go to here, so this will be 1, click apply. Let me move this to here. Then we are going to select the next one, will be banks. For banks, the risk value is 2. Apply. Then chapels. Chapel will be 3. Housing. We can use also the select by attributes to select the fields, but I'm using the attribute table. So housing, there are a lot of housing in this map. So housing here will be risk value 3 as well. Library will be 4. It's only 2 values, so I can type directly here on the attribute table. Then municipal services, 2 as well, will be risk value of 2. Police station, there's one police station only, so value of 2 as well. Then school, we have a lot of buildings of school type. So school will be a risk value of 4. Then shopping center, level 4 as well. Social center, 4. And I think storage, no, it's not the last one. Storage will be 5. And finally, theater will be 5 as well. So there we go, we have the risk value for the topology. Then we can do the same thing for floors. So if I move this to here, we have the risk level for floors. So let me sort ascending the floors as well, and we do the same process. So we can select buildings that have 1 floor only first. There we go. And calculate field. Again, we need to select the calculate field for this field. For this new field, we can close this one. And for buildings that have 1 floor, the risk value will be very low. So we give the value 1. Next, for buildings that have 2 floors, we'll have the value 2. We don't need to open a new calculate field. So floors 2, risk value of 2, as you can see here. Next, the bank buildings with 3 floors will have a risk value of 3. 4 floors risk value of 4, and finally 5 and 6 floors, the risk value will be 5. I'm always opening this one, but I don't need to open. So 5, click apply. There we go. We have the 2 risk values for these 2 variables. And next, what we need to do, let me see here on the steps. So we add the risk values to the buildings and other shapefile. So to the topology here and to the floors. And next we need to select by location building and others plus the response time, and use the have their center in this example. Okay, so let me go to select by location here. And we need to select buildings and other. A relationship will be have their center in, and the selecting features is response time, and we need to click apply. Oh, okay, actually we need to do something first. So as you can see, all the variables, all the buildings were selected because we need to select buildings that have their center in the response time shapefile, but we didn't select any of the variables from the response time, so all the buildings were selected. So what we need to do is, let me go here and select the response time circle one by one. So first we do this, so we select the 100 meters first, we click apply, and there we go, we have the buildings that have their center inside the 100 meters mark. Okay, so we open the buildings and others shapefile. As we saw earlier, buildings that are in the 100 meters or less will have a risk value of 1. So the response time of these 6 buildings will be 1. Let me clear the selection. Select the second mark and click apply. For the 250 will be the value low. So we change this to 2. Clear the selection once again. Let's select the 500 meters mark. Click apply again. This will have a risk value of 3. Clear the selection again. Let's use this one now. These buildings will have a risk value of 4. And finally, the last mark. A risk value of 5. Okay, very high, because they are far from the fire station. Okay, we are almost finishing this part. Then we need to do this step here. Create a special join between buildings and others plus streets using the closest relationship. Okay, so let me clear the selection. We right click on buildings and others, go to joins and relates, and click on Add Special Join. So we are going to use the buildings as the target features and join with the streets, and the match option will be closest. So we need to select the streets that are closest to each building. Let me click OK. And what we are going to see is that this table have more values, and we have here the width of each street closest to a building. So, for example, this building have the closest streets have a width of 2. It's probably this one here. And what we need to do is give risk values as well, using these risk levels here. As you can see, we don't have the risk value 4, but we have 1, 2, 3, and 5. Okay. Let me ascend this width, and I'm going to select all the buildings that the closest streets have 1 meter of width. So these ones, and we need to fill this R streets field. So calculate field, and streets with 1 meter will have a risk value of 5. Then streets with 2 meters will have also a risk value of 5. Let's apply. Then 3 meters will have a risk value of 3, medium. So here with 3, we need to select all the streets with 3 meters. So 3 meters risk value of 3. 4 meters will have a risk value of 2. And finally, the buildings that are closer to these 6 meters street will have a value of 1. We can remove this join, go into joins and relates and remove all joins. Let me close this. Let me look for the next step. So the next step is to convert this shapefile into a raster using these terminologies. So to do this, this is very simple. We go to analysis. Let me actually increase the size. So we click here on this arrow, click on more tools, and we search for polygon to raster, since we are working with polygons. So polygon to raster. The input features will be always the buildings and others, and we need to export this feature using these 4 fields we create earlier. So first is 1. I will save this in my predefined folder. So this is the typology. So we'll give this name here. So I'll copy this and paste it here. Cell assignment type will be cell center, priority field none, and cell size, since this is just a city, we will use 0.5 as our cell size. Okay. Environments, we will use the current map coordinate system, and extent, I will use the area of interest. Okay, and hit run, and we do this for all the 4 variables. There we go. We create the first one here. Then the second one will be the floors. So the name for the floors will be this one. Run. Next, the response time. And finally, the street width. Street width. And run. Okay, there we go. We have all the rasters that we need. Let me just uncheck these shape files here so we can see the results. Streets width, I actually will give this a more obvious color ramp so we can see these values here. So actually can use this one. I will use this from green to red. So this is the streets width. So these buildings here have higher risk and this lower risk here. We can do this to all of them so we can see okay, here the response time. These buildings will have a lower response time because they are near the fire station, and these buildings here right at the back will have the risk value of 5. Okay, then we can do this for the floors. This is not mandatory. I'm just looking if everything looks okay, looks correct. This one, we can see these buildings have a higher number of floors. And finally, the topology. As well, okay? So everything is from a scale from 1 to 5, and what we need to do now is using the raster calculator, okay? Search for raster calculator, and the equation we are going to use is this one. Typology will have a weight of 40%, and floors, street width, and response time 20%, okay? So we just need to use this equation here. Actually, we can see everything because it's cut. So since we have 4 variables, we need to multiply by each variable by the weight, 40%, 20, 20, 20. Sum all the 4 variables, and finally divide this with 4 to have a scale from 1 to 5 as well. Okay, so we can actually copy this. This is the equation we need to use, and I'm going to save this as, actually let me, R for risk and urban fire. Save, and let me select the extent as area of interest and click run. There we go. So we have values from 115 to 3.6, and we can actually use, I will use the classify quantile with 5 classes, okay? So go to Symbology again, change this from stretch to classify. Okay. And I will use the method will be quantil with 5 classes. We can change the color scheme to this one and give the risk names we assign in the Excel. So here we have our final result. Thank you for watching. If you like this type of content, don't forget to like, subscribe and comment what you want to learn next.